million years ago when I was a resident, we naively believed that all of the inhaled anesthetics went into the body and came out of the body unscathed. And we know that's not true now. We know that the inhaled anesthetics are metabolized, aren't they?
Yes.
Are there any that aren't metabolized? None at all. How about nitrous oxide? Even nitrous oxide. Do you know what metabolizes nitrous oxide? Intestinal bacteria. That's what metabolizes nitrous oxide. It is the one anesthetic that the liver has a little difficulty with, although even the liver may metabolize a small fraction of nitrous oxide. We know that they are metabolized, but we know that there's a difference among the anesthetics in their metabolic rate, that some are more metabolized than others, like on animal farms, some are more equal than others. And the older anesthetics tended to be metabolized. Chloroform, which is not on here, methoxyflurane, which is not on here, and halothane, which is on here, this slide, are all highly metabolized. Methoxyflurane was metabolized so much that its metabolism very significantly affected its uptake. Over 3/4 of the methoxyflurane that was taken up was metabolized. And you can see with halothane, 20 to 40% of the anesthetic taken up is metabolized. But the modern inhaled anesthetics are resistant to the capacity of the liver to degrade anesthetics, particularly desflurane and isoflurane, and to a lesser extent, enflurane and sevoflurane. The metabolism usually is an oxidative form of metabolism where the molecule, the anesthetic molecule, is attacked at some junction between the carbon and the hydrogen. The oxygen, an active oxygen, is inserted there, making an OH group, and this rapidly decomposes to this double bond group. Water is added, this splits, and we get two compounds, one of which is further metabolized to hydrogen fluoride and carbon dioxide, and the other forms trifluoroacetic acid. That's the pathway for isoflurane. And a parallel pathway, an identical pathway, is postulated for desflurane. Again, the insertion of the oxygen and ultimately the formation of trifluoroacetic acid and two fluoride ions. Sevoflurane is similarly biodegraded. So we get an insertion of an active oxygen, we get a splitting of the sevoflurane molecule, the formation of hexafluoroisopropanol, which then is conjugated with glucuronide to form this compound. Now that's important. It's important because this compound, hexafluoroisopropanol, is a potent anesthetic. And if it weren't conjugated, the anesthetic properties of sevoflurane would be augmented by hexafluoroisopropanol. If it were, that would delay recovery because hexafluoroisopropanol is not an anesthetic that disappears from the body quickly. It has a half-life in many hours to many days. So it's fortunate that the body knows how to deal with this, glucuronidate it, and make it an inactive molecule. Except, and this has really never been studied, except that the ability to glucuronidate compounds is very limited in the neonate, in the very young person. And we don't know whether that may be a factor that may contribute to the rate of recovery in very young people, the neonate, where, of course, sevoflurane may be particularly useful. I should go back a slide and note that this metabolite, the trifluoroacetate, is the one we talked about earlier when we talked about the potential for an immune response that would attack the liver in patients. And we'll return to that in a little bit. What do the words enzyme induction mean to you? What does enzyme induction mean?
You have increased production of certain enzymes that metabolize, and that can be induced by drugs like phenobarb or ethanol, sometimes obesity.
Exactly. Exactly. So if we have a patient in whom enzyme induction has been produced, that patient is likely to metabolize more anesthetic. And if there are any detrimental effects of the metabolism of the anesthetics, it will be more evident, or should be more evident, in such a patient. Here's an example of the effect of enzyme induction. Urinary fluoride excretion in enzyme-induced rats is increased and, in fact, becomes very large after enzyme induction for an anesthetic like sevoflurane, where it was almost unmeasurable for desflurane. It now becomes a little bit measurable, particularly the organic fluoride component of desflurane. So that's after pretreatment with phenobarbital.